In college algebra, we moved on to 3.6, polynomial and rational inequalities. So the main thing you should notice here is we just have one variable. So we're just talking about a one-dimensional number line. All right, we're not talking about not XY plane. All right, we are just talking about a 1D number line. It sounds pretty easy when you say that, but it's a little tedious to find the correct range of values that are solutions. So what you do is you start by solving this by setting it equal to 0. So let's move the 15 to the other side, to the left side. And then this is factorable. So we're going to go 2x and x. See, we end up with a positive 1, so I bet we could add 3 right here and subtract 5. Yeah, that gives us negative 5x, and 6x, that gives us 1x. So you set each equal to 0. And you get 5 halves and negative 3. But you're not done yet, because we have a greater than. So we go to the number line, and we know that we have 2 spots of interest. And what you need to do is plug this right here is telling you to plug in values to determine range of solutions. In other words, let me get a different color. Is our answer here? Or is it here? Or is it here? Or maybe it's both here and here. Usually it's either both on the outside or just on the inside. So we need to test values. So let's test easy numbers. Let's test just left of it, in between, and just beyond. And by testing, I mean plug into the typed equation and see if you get a true statement. So I'm going to test negative 4. And we'll see if that's greater than 15. And I believe it is. So we have one answer. We know part of our solution is going left of negative 3. All right, let's plug in 0. You probably already know the answer here. And 0 is not greater than 15, so not 0. I bet 3 checks out, because usually if it's on the left side, it's also on the right side. And yeah, 9 times 2 is 18, plus 3 is greater than 15. So our second solution is over here. Let's use an open dot, because I don't see it, or equals, and we are done. All right, move on to number 2. Same exact process. Solve it like you usually would if it was an equal sign, and put it on a number line, and then test values in between. So I'm going to get everything to the left with the x squared. And you could try and factor this one. I tried earlier and it does not factor. For example, 4 times negative 1 is negative 4. There are not 2 numbers that multiply to negative 4 and add to 2. So let's do quadratic formula. So I'm going to plug in way over here so I have room. Negative b plus or minus b squared minus 4 times A times C, all over 2A. So I do a little bit of simplifying, and I figure out that I have a 20 in there. Simplify a little more. This still isn't all that helpful because that's not on a number line. So let's get some actual numbers. Let's type it in. I typed it in and I got one answer as negative 0.809 and I got another answer as positive 309. So throw that on a number line. I'm going to conserve space here. And we're going to plug in numbers to test. So let's plug in negative 1. Let's plug in 0. And let's plug in 1. That should go on like that. All right, so in red, I'm going to be testing numbers. Let's plug into the typed equation. Is 4 smaller than 3? Nope. Let's plug in 0. And is 0 smaller than 1? Yeah. We have an answer. I bet 1 will not check out. But just to be sure, maybe it's a weird one. Or maybe I made a mistake with the 0. It's good to check all the zones, if you want to call them that. But no, 4 is not smaller than negative 1, so not that one. I do see it or equals, so this time I'm going to make a solid dot. And we got our answer. All right, let's try number 3. Same exact process. I'm going to move everything to one side. This expression should look familiar to you. We've factored it before. Factor by grouping. We're going to take a GCF out of the first two, a GCF out of the last two, and get something that looks like this. Then I take x squared minus 4. Then I factor x squared minus 4. And I get 3 answers. So plot those on a number line. And we need to test all the zones. So let's plug in negative 3. Let's plug in negative 1.5. Let's plug in 0. And I'm plugging right into the typed thing. So plug in negative 3. And I get negative 27 plus 9. That looks like negative 18 to me. Negative 12 plus 4. That looks true, right? Let's plug in negative 1.5. I would have a calculator for that one. So when we cube 1.5, we get negative 3.375. When we square 1.5, we get 2.25. 4 times negative 1.5, we get negative 6 plus 4. On the left, we have negative 1.125, smaller than negative 2? No. Let's plug in 0. That one will be very easy. And I think 4 is bigger than 0. There's another solution. Okay, so we have a solution here. A solution here. Oh, and I forgot to plug in 3. We got to plug in positive 3. Man, I thought we were done. We need to test that zone. Sorry. It would be confusing if I didn't test that zone, but it could be a solution. You never know. 27 plus 9 is 36. I don't think that's smaller than 16. So that was easy. It is those two shaded regions. I see it or equals, so make solid dots at all the red spots. And that's it. All right, moving on. Number 4 is very weird. So I give you the steps. Whoever thought this up is very clever. I approached it from a different angle and I filled up the paper with math, but this is a simple way to approach it. Well, I say simple, simpler than I was doing it. Let's set it equal to 0. And I need to combine the negative 2 with that fraction, so I need a common denominator. So if I multiply that 2 by x plus 3 and throw it in the denominator, then I have a common denominator. So now we have x plus 1 minus 2x minus 6 all over x plus 3. We have negative x minus 5 over x plus 3. All right, so I did step number 1 that I typed. I set it equal to 0, and I combined it into one fraction. Step 2 is very easy. We got through the hard part. Set numerator equal to 0. Set denominator equal to 0. And we go like we did before, and we test the zones, if you want to call them that. So let's test negative 6, negative 4, and 0. We need to plug into the typed equation. So back to the beginning. I'll use a different color. So the red is me plugging in. So we're going negative 6 plus 1 over negative 6 plus 3 greater than 2. And I don't think that's true. It is positive, but it's not 2 or larger. So not that zone. Plug in negative 4. We get negative 3 over negative 1. And that does check out. Negative 3 divided by negative 1 is positive 3. So there's an answer. I bet 0 won't work. Let's try it. 0 plus 1, 0 plus 3. Yeah, 1/3 is not greater than 2. Not that zone. It does say or equals, so let's make solid dots. All right, last problem. It's a physics problem, and we're throwing algebra and physics together. So it defines two of the variables. V naught is the initial velocity. S naught is the original or the initial height, which is the height of this tower, the Leaning Tower of Pisa. So let's change the function. Let's plug in, I should say. So V naught, initial velocity, is 96. And the initial height is 190. Starting, being launched from 190. Now it asks an interesting question. Notice I didn't write down S of t. During which time period will the ball's height, this is the height right here, exceed the height of the tower? When will that thing I underlined be greater than 190? And that makes it actually very easy, because don't the 190s cancel out? And we have negative 16t squared plus 96t greater than 0. Conveniently, 16 goes into 96. Factor out a 16t, and we have t minus 6 left. That means t equals 0 or positive 6. Now, if you're familiar with quadratics, you probably already know the answer. But just to be sure, we're going to test -1, 1, and 7. And whenever we get a true statement, then we got it. So I'll use green. So that gives me -16 minus 96 plus 190. Is that possible? I don't think it is. Let's try 1. And that has to be true, right? Well, I guess it doesn't have to be, but I hope you see that it is, because 96 is larger than -16. It's going to be larger than 190. The answer is in between. And doesn't that make sense? Because at 0 seconds it launches, and at 6 it passes the height of the tower. At -1, that would be back in time. At 7, that would be passing the line of that imaginary line of the height of the tower. If you don't trust it, plug in a 7. And notice we're squaring 7 there. That's going to mess up this inequality. When you do that, you end up with, this video is too long, 78 on the left side. I hit pause and I did some math, which is not true. So that range right there, 1 to 6 seconds. All right, bye.